Okay, hello everyone. I'm John from Nickfin Gaming, and today we are going to start our first episode of 1 hour long classes about building a brick breaker game. So I have the latest Unity editor version of 2021.3.21 F1 long-term service, and I'm using the 3D core because while this is a brick breaker game, we are going to be building it with 3D. Now, I have named it Brick Breaker. I will definitely change the project name later, but lacking a better name, I'll name it this. We also don't want any spaces in the project name, just because that can cause complications later on if you have spaces in your file name, because this will also be built for the Android device. So we are currently building our project, and while we are waiting for this, I will just give a quick outline of what we will be doing with the Brick Breaker game. So we are going to be creating a 3D brick breaker. I do not have any assets for it at this time, so we will be just coloring the 3D objects. And we will need to create a ball, we'll need to create a paddle, and we'll need to create the bricks that we break. We will need to create a few scripts. We'll need a ball launching script. We'll need a ball moving script. We'll need a brick breaking script to break the bricks, give them health as well. We'll need some upgrades that will modify the ball or create more balls to match with the popular brick breaking games. And we'll need some levels. Let's see, what else would we want? Well, let's go into Photoshop and kind of detail what exactly we want while we are waiting for the game to build. So, as expected, our game will have our paddle, it will have a ball that is moving, and it will have a set of bricks that we want to break. And let's do that for the drawing. Okay, so for our scripts, we need our brick health, because I want the ball to do damage. We need on our brick, we also need a collider. We will need our paddle mover, which will also have a basic collider. And we need our, and the paddle just moves left to right. If we want it to be a bit slick, we can have a rigid body. So if you want the paddle to keep moving after you let go of the button, then we would use something like a rigid body with a velocity. But I hate that, so I will not use it. So movement needs a rigid body with velocity. But what we will use is we will use the vector 3 times time dot delta time. Okay. And the final thing is we need the ball. And the ball will have a collider and rigid body. For the ball controller, the most complicated part that I can think of is going to be the bouncer. But first, let's talk about this. Oh, and the rigid body, I believe, will be kinematic. Oh my, that did not write well. Okay. And on the ball, we need a bouncer. What I'm imagining is when the ball hits here, it will rotate 90 degrees. So this would be about negative 90 degrees. And then it would go this way. And then we have our paddle, and it hits our paddle, and then we would need it to reverse directions, and, well, we have two things. If we add another 90, it would just go straight like this. We also don't want it kind of bounce this way, so maybe have it bounce this way, which would be a positive 90, I believe. Or even 45. We'll have to experiment with it, see exactly what we want, and then, yeah, it hits the wall here. I'm not sure if that would be 45 or 90. We can even pick a random number between 45 and 90 for how much it moves. We will either probably destroy the brick when it hits it. So our ball also needs a damage. But okay, that's the general idea behind what we want to do with this game. And while we're here, let me actually open up my clock, because I do want to have a 1 hour timer. So let's go 3 minutes, 1 minute, 10 minutes, and 5 hours. Let me add a new timer for 1 hour. So 1 hour, let's save. I will play it, and we can end this stream in 1 hour. Let me also add that, so display capture. Do I want to display capture? No, I don't think I want to display capture. Let me discard. Oh, and it's switched my display capture anyways. Delete this display capture. Oh, and it's stopped my video capture. How odd. Window capture, display capture. Okay. There we go, now I'm back. So let me see, what else can I do? Window capture, maybe I want that one. And can I add the clock? Nope, I am not not allowed to add the... Huh. That's too bad. I might not be able to capture the clock. Capture. What does that... Okay, so no ability to capture the clock, but I will have it either way. So let's open our Unity scene and let's get started on what we want. So first I'm going to import a few assets into the scene. Let's also make the build settings. I will switch it to Android. I will build it for Google Play at public debug settings and start switching platforms. This can take a while. So yeah, let's see. The first thing we'll do is we will toss some assets into the scene. I think I will create a very basic brick script and then just create a quick array of bricks. There are two ways to handle this as well. Add open scene. So without further ado, let's go assets, create folder, and I will call this scripts. In this script, I will call it the create C# script. I will call it the brick controller. And I will open it in my Visual Studios. If you have trouble with Visual Studios, then you may need to actually connect it to your Visual Studios. So let's see if I'm able. Okay, I need to reload the scripts. There we go. So if we go edit, project settings, editor, I believe, or perhaps it would be the scene templates, perhaps not. Let's see, I felt like it would be the, maybe preferences. Yes, there we go. Preferences, external tools, and make sure your external script editor is Microsoft Visual Studio and whatever Visual Studios you have. If you want to use Visual Studio Code, select that, or whatever else you have. And then once you have done that, then you should get your Unity built-in things here. Okay, so the first thing I want to add to the brick controller is going to be health. I will have it as an int health, and I'm going to set it to 1 by default. And then I also want an on collision enter. And then I will say if the collision collision dot, we want the tag from our collision. Looks like collision dot game object dot tag. There we go. And we'll say if this equals and we want this to equal our ball tag. So let's create another C# script, and this will be the tag holder. Okay, let's open that up, and this will just be a public enumeration of tags. This is not going to be a class, it will be a public enum tag holder. Now the first thing that we have, let's also delete all of these, okay. So I will have it be called ball. We also have brick, and we have paddle. These are the 3 tags that we have, so then I will say tag holder dot ball. So if the collision object is the ball, then we want to get the ball script. So now let's go back one more time. Well, not one more time, but another time. Let's do create C# script, and we'll call this the ball controller. Now the ball controller is going to have a serialized field for int damage, which will be equal to 1 by default. It will also have a serialized field float of speed, which let's say is 10 for now. Let's have it have a bool for is moving. We'll also have a game controller later, but let's not add too much. Okay, and then let's have an internal void of deal damage, internal int of deal damage, which will return damage. Okay, then back in our brick controller, we will say health minus equals collision.get component of the type ball controller dot deal damage. Then we say if health is less than or equal to 0, then we want to say destroy this. Okay, then over here we want to say on collision enter, we will say, you know what? Let's make the ball we'll need to have the ball be a trigger, I believe, because we don't want the balls to bounce into other balls. So instead of on collision enter, this will be on trigger enter. So on trigger enter. Okay, then with the ball on collision enter, it will say bounce, where it will say transform dot rotate And I'm not really sure how we want to do this, so we'll, for now, just say new vector3 of maybe 0, 0, and then let's try 45. See what it does. We also want an update where it says if is moving. For now, we will say transform dot position plus equals okay, so this would cause a bit of an issue because we are dealing with a 3D object. We don't want it to move on the I believe Z axis. We just want it to move on the Y and X. But we also have it rotating. So perhaps I'll rotate the ball so that forward is in one direction. So it will be plus equals vector3 dot forward times speed times time dot delta time. Now, update is ran once per frame, which means if your game is currently running at 60 frames per second, update is ran 60 times a second. If your computer is lagging, maybe your update will run 1 time a second or 1 time every 2 seconds. So for that we use time.delta time, which as it says is the interval in seconds from the last frame to the current one. So this is the time between updates. So update is every frame. And of course only if the mono behavior script is turned on. So let's save it. I also want another script, so let's go back to our scripts and let's right click, let's create a C# script, and I will call it a paddle controller. Now the paddle controller is going to moves left and right depending on the mouse position. Now you can use the mouse position in Android as well, because as you hold your finger on the Android screen, the Android will actually create a mouse cursor at that point. Interestingly enough, I'm not sure if that's default to Android or something that Unity does itself. But let's do a serialized field because we do want our camera. So let's add camera cam. We can't name our camera camera because that would override the default mono behavior camera, which we can't access anyways, but it's some weird stuff. Okay, and then we want to say update. And then we want to say, let's actually have a static bool of game active, and we will say that equals, we'll have it true for now. Then our ball controller will be is moving, and paddle controller dot. Okay, we need an internal static bool game active so we can access it from other scripts. Dot game active. There we go. So over here we say if game active then we will say because we'll add this script onto the paddle, so we want transform dot position equals new vector 3 of, or what if we do a plus equals a new vector 3 of cam dot screen to world point of the input dot mouse position dot x comma, and then let's just do this of serialize field float of paddle height, and it will be a y of paddle height. Okay, now let's go over to our scene. I'm going to change it from free aspect to a 16:9 landscape. I will drag it over. Sure, we can keep our directional light. I will say create a 3D object of a cube. This cube is going to be the paddle, which will have the paddle controller. Sure, the paddle can be at 0. However, I do want to stretch the y out. 4 seems good. Let's give it a -3. I think a height of -3 is perfect. Let's add that to the paddle height. Add the main camera to the camera. I do want a thing to start the ball controller. So I'll say if for now input dot get axis of fire 1, then we say is moving equals true. Is sorry, not get axis, but get axis raw, and then fire 1 greater than 0. If we say get axis, then it will return a float from 0 to 1, so 0, 0.1, 0.2, 0.3, all the way up to 1. And it would slowly move up and slowly move down as you push the mouse button and release it. But the get axis raw is a solid value of either 0 or 1, and it's better for things like this, that you don't want to have a gradual tapering off of. Okay. So that would only start the ball moving when we click the fire button. We already have a box collider, which is perfect, and it is not a trigger. Let me add a 3D object. Let's add a sphere this time, and this will be our ball, which will have a ball controller. Let me move it down to, I think 2 is a great height. Yeah, let's do -2. I can even shrink the height of these, so this will be 2.5.5, and this will be 0.5.5.5, meaning we need to move it down to -2.5. we also need the forward, the Z, to be up, which means let's rotate the X by -90. So the Z is the forward axis. And then let's add some bricks. So 3D object, cube, and I will call this the brick. I think I'll make this 2.5.5, so the same size as our paddles. 0, 0, 0. Having it up 0 seems fine. Let me add the brick controller. Let's save it, and let's just try this out and see what we have. And if I click, and forward goes towards the camera. Okay, so let's test out some more. What if I have a rotation of 0? What does that do to us? And I press. Now forward goes the wrong way again. Perhaps we need to do something like up. Perhaps the rotation doesn't matter either. One last try. Yeah. So it is moving in the Z. What happens if I rotate the Z? And what if I rotate the Y? So, okay, it doesn't seem to matter there. So we need to, because we are not actually using that, I will say 0. We'll try rotating it later. And then what if we do vector3 dot up? So now it's going to move up. Let's play. Click. Okay, that worked. And we ran an on-trigger enter, which is great. We did get an error, but that's fine. Let me reduce the speed of the ball. Let's get this on-trigger enter. The message parameter has to be of type collider. That's interesting. We do want to add some tags, so let's add our tags. Now we have the ball. Let's look at our tag holder, brick and paddle. Brick and paddle. Let's go to our ball, tag it as ball. Go to our brick, tag it as brick, and go to our paddle and tag it as paddle. We also want to say the sphere collider is a trigger. And try again. Click, and then the ball hits, and we get our error again. What if I set it back to 0? I say -5 so we can see it move up. And the rotation does not seem to change because it's moving in the Z. Then in that case, I think we should add a rigid body. We'll say that it is kinematic. The constraints, it will freeze the position of y. Here, let's rotate it as we want it. So negative 90, we see x and z. It's going to freeze the position y, and it will freeze the rotation of x and z. So it will only rotate on y, and it will only move on x and z. That should be fine. And then in our ball, let's grab the rigid body, so serialized field, rigid body, and we'll call this the RB. And then let's try our instead of transform dot position, we're going to say RB dot velocity equals, even plus equals perhaps, and velocity is, if we highlight over it, the velocity vector, it's a vector 3. So let's try vector 3 dot forward times speed times time dot delta time. Or we can even just set it equal to instead of plus equals. We have about half an hour left in this episode, so let's keep looking at what we're doing and trying to figure these things out. We do need to assign the rigid body of the ball. So let's just drag ball over the rigid body. Let's save it. Not quite sure how exactly we want this to work, but that's why we're doing our testing. Okay. What if I unfreeze that? Perhaps because we say it is kinematic. Let's see if that's the solution. And why would we be having this on trigger inter error? Well, when in doubt, look it up. Okay. So it looks like it just had an issue with us saying collision, which is what Unity made by default. But we did switch it from on trigger enter to on, or on collision enter to on trigger enter. Okay, perhaps it is moving. It is moving, it's just very slow. So what if I set the speed to 10? And if we look in the inspector, it is moving in the wrong position. Okay, what if we set this to 0? very odd. It's ignoring all of our controls and commands. And it doesn't seem to be using the rigid body. How odd. Let's see if our paddle will move with us, because I haven't seen the paddle moving either. So the paddle is not moving at all for some reason. We aren't setting game active to true, but it should be true by default. Well, let's try printing out Y. So if we print it, yes, it's running, it's in there, but the screen to world point, perhaps that's off. So what if we get this? And let's try printing that, see what that is. And see if we can change it by moving our mouse around. Oh, it's always 0. What if we get the whole thing? What value does the whole thing give us? We might need to set this to string. 0, 1, -1, 10. That is not at all where our mouse is. That's the camera. I believe that's the main camera position. Yes, that's exactly the camera position. World to screen point, perhaps. Let's try flipping the script around. Curiouser and curiouser. Okay, well, it's definitely moving it somewhere. Where is our paddle? How interesting. It's so odd. It should be moving it with the screen to world position. What about viewport to screen point? What does that provide us with? Oh, and we can close this. Try to find a method that works. Okay. And we've got crazy values again. Should be screen to world point. What else do we have? Input. What if we just do input.mouseposition.x? Let's try that. Perhaps we're overthinking it. We've got about 15 minutes left to make this work. should be mouse position. Well, when in doubt, Google it. So let's see why this is not working. Unity have object follow mouse. To make an object, you know what? Perhaps it's because we're using 2D and we want 3D. Transform dot position. Well, let's try this. We've got nothing to lose. Delete the extra trash that they add. Change screen camera to camera. Change mouse position to input dot mouse position. And the Z distance will be 0, I believe. Looks like we need an extra bracket there. Okay. Let's see if the quick forum post fixed it. Nope. Still stuck at 1, -10. Huh. How interesting. Why is it not grabbing the mouse position? Screen to world point. Do we have screen to world point? Yeah. I really feel like that was supposed to be it. Huh. Unity. Screen to world point. Not returning camera position. There we go. That's the issue we have. Position, touch position, Z. Nope, that's not it either. What about this? Okay, so what if I say 10? Could our problem just be that we kept setting Z to 0? Yes, there we go. Now it's following. Finally. So this will be paddle height. Let's save it. We want to lock the mouse on screen later. Oh, too low. It's at -4. Why is it at -4? About -2. Because input dot mouse position dot x so let's say vector3 mouse position is equal to this, then we say new vector3 of mouse position dot x and then paddle height. So we grab the y anyways and then we just ignore it. 8 minutes. Let's see if we can get a bounce working. Okay, well, our paddle is moving as we want. If we click the play button, our ball starts moving, but not only is it moving very slowly, it is not moving in the direction that we want. If we rotate, it is still not moving in the direction we want. What if we just say, okay, vector3 dot 1 times, what does that do? Might need to look it up next. But at least we have the paddle moving. Nope. Still refusing to rotate. Huh. Okay. So Unity. Sphere not moving with rotation. I feel like none of these problems should be happening. Unity. If I try adding the script to a cube. 3D object, cube, add our ball controller, add a rigid body, okay, we'll have the rigid body, a speed of 1. Okay, let's try this. Okay, we need to turn the box collider to a trigger so it doesn't spin. Okay. This is interesting. Let's try to freeze these rotations. Set it to zeros. Okay, maybe -2. Let's try this. Unity vector 3 dot forward, not moving with rotation. Oh. Okay. So what if we do transform dot forward? Let's try that. Freeze the position of the Y as trigger. Okay. And click. Give it a speed of 2, so it's and if we rotate it, a speed of 3. Okay, that did something. 0, 0, 0. Change the no. Change the X. No. So it should be the X. Let's give it an X of 90. An X of negative 90. A speed of 10. Why do I have to have such a high value? It's completely ignoring the speed. because I have the freeze position Y. Okay, there we go. So I can't freeze position of Y. Well, maybe I need freeze position of X and Z then. Either X or Z. We'll figure it out, but okay. Delete the cube, put the ball back, remove the position of Y, still freeze those rotations, put X at -90, save it, and it should work now, and we are right at the end of our time, so it would be great if this works. Give it some faster speed. Okay. And then if I rotate it to 90, it would come back down. And then what do I need to rotate? Not the Y, but what about the Z? Okay, perhaps I need to okay, so everything would be controlled through the movement of the X. Okay, so well, we are almost out of time. So let's set this to a speed of 20, damage of 1. Let's say control the ball with rotations of X. And so what if I just say this is 45 with on collision enter. Let's also add a print so we know that it's triggered. Okay. The stream is going on for an hour and 4 minutes. We wanted 1 hour, but our timer's down to 4 minutes, so that's fine, I suppose. Okay, and we're going, and we're going, and we're going, and oh, it never triggered. Did it not trigger because it is not a collision? Okay, so what if we change it from on collision enter to have an on trigger enter? And let's try that. What if we change our brick to also be a trigger? Perhaps we need, you know what, maybe we need a rigid body on our brick to work as a collider. Oh. It triggered. But okay, that's not the rotation we want for it. So we need to freeze the position of Z, I suppose. Yeah. freeze the position of Z. It's here. It's triggered. Still not moving left to right. Oh. What if we move the Y instead of the X? We'll need to put a timer on it. Perfect. So yeah, it will rotate, heck, maybe even 180. We'll need to add a timer, so let's say add timer, and these will all be done in our video tomorrow. And one last thing, in our brick controller with our on trigger enter, let's print entered, and that will be our final act because our timer is down to 10 seconds. Okay, and printing. Oh no, we're going the wrong direction. Let's try -90. Okay, go back. Timer's up. Okay. Let's just see if it gets there. And triggered and entered. Oh. Then we'll need to print out the health. But this will all be looked at tomorrow. So day one, we've got the paddle, we've got the ball, and we've got the brick. They are mostly working. They still need lots of tweaking and all that. We need to add some colors, but this is good for the first hour's work. So thank you for watching, and